My name is David Beard. I am the developer evangelist for the Vuforiaro augmented reality platform. I started several years ago with Vuforiaro, about 5 years ago, as part of the engineering team when we were a research and development group. And then I moved on to the product management team. And really my responsibilities now are for tools like Unity and also OEM engagements and also largely to help with training of developers, to familiarize them with Vuforiaro, how to work with the Vuforiaro platform, how to use our SDKs and our APIs, and just get them up to speed, with the opportunities for augmented reality. So during today's session, which is really about mixed reality, I'm going to give you an introduction to the Vuforiaro platform, and I'll talk about how we're enabling new kinds of mixed reality experiences, and I'll give you an idea of our vision for that. And I'll also get you into a hands-on workflow with how to use Vuforiaro to develop a mixed reality application. So when I talk about mixed reality, what do I mean by that? And you've probably heard about virtual reality, which is that you are in a fully immersive world. Everything that you see is being rendered for you. And the distinction between virtual reality and augmented reality is that in augmented reality, you're actually looking at the world around you. And you're using objects in the world, and you can recognize them, you can understand where they are, and you can actually render virtual content on them. So when people talk about these two different modes of experience, they often say that augmented reality is on one side and virtual reality is on another. And in between, there's a continuum of mixed reality between the two of them. So that's really the topic of our discussion, is what does that mean? What kind of experiences can you build with that understanding, and how does Vuforiaro enable that? So just as some background, Vuforiaro is a mobile augmented reality platform. And what that means is that even from our beginnings, we've focused on computer vision and taking the best computer vision algorithms available and building them really from the ground up so that they can run efficiently on mobile devices. Computer vision, as you can imagine, is very computationally intensive. It tends to use a lot of processor cycles, it uses rendering, it heats the device, it can result in downclocking. You really have to focus on making very, very efficient algorithms. So that's been a lot of what we've done. The second thing is to make it as easy as possible for developers to use computer vision in a mobile application without having to have any background in computer vision sciences or machine learning or some of the harder mathematics that are involved. And so we focus on making computer vision very efficient on mobile devices and also making it very easy to use for developers who just want to create games and interesting experiences without having to learn a new science. So Vuforiaro provides a very simple API to do this. And currently, we support the recognition and tracking of a variety of images and objects. So when I say recognition, what I mean is that we can actually uniquely recognize an image like this. You can add this to our platform, and we can tell you, oh, this is the Stones image. We can recognize it from millions and millions of other images that may even look very similar. So that's recognition. And tracking is when you know this is the Stones image, and it's this far, or maybe it's this far, and it's tilted in this direction. That's called a pose. So we can tell you where the image is relative to your camera. And what that enables you to do is to actually render digital content onto the surface in the view of the camera so that you can make it look like that content exists in the real world. And that's really the principle of augmented reality, is that you can put virtual content and virtual settings into real world settings and make them look realistic. So we support images. We also support the ability to detect and track images that are wrapped, let's say, into a cylinder or into a cone. We can detect images that are made into an array of a defined geometry, like a box or a fan. Right? So besides images, we can recognize text, which is really English language, Roman characters. We can also recognize three-dimensional objects. Let's see if I have a good example. So something like this, where we can understand the pattern of contrast variation on something. And if it has a consistent geometry, if it doesn't change, if it's not like a pillow, if it's not plush, or it doesn't have a lot of moving members, if it doesn't have articulating members, and it's consistent, we can recognize objects, typically. Here's a better example. Let me show you. Something like that. Our SDK, the significant thing to understand is that we look at the pattern of what's called contrast variation. So we take the image, we reduce it to grayscale. So it's really the range of black to white and all of the gray changes. And those are the features that we look for. It's not color, it's not really shape, it's to understand what features are apparent when you change this to black and white or into gray. And we look for sharp changes in the threshold value and the gradient value. And that's how we distinguish the features of something in relation to other things, basically. So again, images and objects, we can recognize text, and we also have an ability through a feature called Smart Terrain that we can, using a device, actually reconstruct the surface geometry of, let's say, a tabletop or a floor setting. And what that does is it returns the basic geometry. It'll give you a plane, and it'll give you objects that sit on top of it as a bounding volume, and it returns that as a mesh. So the neat thing about that is that you can use it to create games that actually exist in the real world, or to visualize products, let's say in your living room. But it gives you an ability to actually reconstruct the physical environment as a 3D mesh. So, as I mentioned, we've been around for about 5 years. And I think because we're so easy to use, and our SDK is freely available to developers, we've grown a significant developer base. And this is currently over 200,000 developers. We have over 25,000 commercial apps in the market. These are apps and app stores, like Google Play, the Apple App Store. And they've been very successful in that we have, or our developers have, over 225 million app installs. So we've seen a great ecosystem develop, and we have a lot of developers who are making businesses for themselves, creating augmented reality applications either for themselves or for clients, developing marketing apps and promotional apps or games and toys, things like that. So the Vuforia platform is really, the offering is broken into 3 basic components. You have the Vuforia engine, which is our SDK. You have a set of tools which are used to create and manage targets. And when I say a target is, again, something that you can recognize and track. It's a specific instance of something that you're capable of tracking. And then there's also cloud services. Our cloud service really provides an image recognition service that exists online, so it's like a web service. And it can support huge portfolios of images, up to 1 million images if you choose. And when you query the cloud recognition service, it returns the same data representation that you would create through the target manager tool, so that you can also track that. So it doesn't only recognize, but it also enables you to follow it, to track it. So to back up, the Vuforia engine, again, is the SDK. We support a broad range of ARM-based phones, smartphones, and tablets. We're also introducing support for Windows 10, and that initially is going to be for the Surface tablet, and also for HoloLens. We support a range of eyewear. Eyewear is like HMD, and basically there are 2 classes. One is an optical see-through, which is like the BT200, if you've heard of that, or the ODG R7, R6. These are glasses that you can see through the lens like a normal pair of glasses, but it actually renders video into the eye, like an HUD, right? There's another class that's known as video see-through. This is like Google Cardboard or Gear VR, and with these, you're actually using the camera of the device to see the world around you. So you're looking at the display, it's mounted in a headset, and you can see the world through your device camera. So for all of these, we have 5 SDK versions. Unity, through a Unity extension for both Android and iOS. We support Xcode, obviously for Apple, for iOS development, and also Android Studio. Unity is a very, very easy to use tool for us, and I'm going to show you that today. Android and Xcode, we provide C++ and also Java APIs for native development. So you're really developing directly with the system. For our tools, again, the Target Manager is an online tool that you use to create target images and also object targets. You upload the target, it gives you an ability to evaluate it, it shows you what features it can see. And then you can package them together into a database that either you deploy on the cloud service, or you can download and actually embed into your application so that all of the images are local in the application, which makes it very, very quick to recognize them. The Vuforia Object Scanner is used with our object recognition technology. This, again, is the one that's capable of detecting three-dimensional objects. And it's an app that sits on your phone that you do a 3D capture process. And this enables you to create really almost like a point cloud of the features of the phone, of the object, and then you can use those as a target. And the other tool is eyewear calibration. This is for optical see-through eyewear. This is a tool that actually exists on the eyewear. It runs on the phone, on the digital, on the HMD. And it enables you to do specific calibration for every user. Everyone's facial geometry is a little bit different. The optical characteristics, what they're able to see is a bit different. And so we have a process that enables you to get very precise calibration for each individual user that may use a wearable eyewear. So now let me start talking about mixed reality. As I mentioned, when we started, our focus was really on phones and tablets, on smartphones, things like the iPad, obviously the Samsung line, LG, iPhones, things like that. And then a bit over a year ago, we started introducing support for, again, digital eyewear. Here are examples of the optical see-through that I mentioned. You can see that you actually look through these lenses. That's the BT200. This is the ODGR6. And we also introduced support for Gear VR, which is by Samsung, and other forms of really what are called viewers in the cardboard vernacular, which is really like a harness that holds a phone. And again, it's used for video see-through eyewear. So what I'm going to talk about today is a new generation of features that we've introduced to support mixed reality, which is the combination of augmented reality and also virtual reality. And we're using these to support video see-through devices. So, virtual reality and mixed and augmented reality are really two sides of the same coin. They use a very similar technology stack. They all rely on CPU for running algorithms, good displays for the visualization of things. And they have different levels of immersion. Again, with augmented reality, you're actually looking at the world around you. And it's familiar. It's like if I'm looking out in the room, but I can recognize elements of the room. But the setting is really my real existence, in a sense, the real environment. Virtual reality is on the other side of the spectrum, in that everything you see is basically rendered in the scene. There's nothing real there. So our vision for mixed reality is that you can use augmented reality to complement virtual reality in two primary ways. One is that augmented reality, if you start a virtual reality experience in an augmented reality mode, it is very comfortable for the user to transition into virtual reality. They're not just being thrown into the experience, they're actually sitting down, they can see the world around them, they can choose how they want to configure the setting that they're using, and they can use AR to then begin to visualize the experience and choose when to transition to VR. So that's one mode. The other is that you can use targets from augmented reality in the virtual reality setting, so that while you're in VR and everything around you is rendered, you don't see the real world, but you can still bring in real objects and make them significant. You can use them as interactive devices in a virtual reality scene. And you can also use them, because you know their distance and their rotation, you can use them to establish boundaries and set up geometry, effectively set up bounding surfaces and other significant surfaces in a VR. So this really constitutes two distinct mixed reality use cases. One, as I mentioned, is transitions. that you use AR to transition into VR, and you can also then use VR to transition back into an AR experience. We have at our booth, if you come and see our setup, is we have some demos that show this. And one of them, for example, is a motorcycle that you look at a target and you immediately get a rendering. You get a model of the motorcycle that you can see in space. And then by interacting with it, you're pushed into a VR world where you see the components of the motorcycle and you can choose them and they'll highlight and get information. And you can gracefully transition back and forth from AR to VR. So those are AR transitions. And again, the other is interacting with VR, which we show in the picture here, which is that you can have a target, again, that is significant in the VR setting. So let me show you some examples of what our developers are doing with this. This is the Mattel Viewmaster. And if anyone remembers, back, I think in the 70s, there was a toy called the Viewmaster, and it was a stereoscopic headset that you would take reels with photos on them, slip them into the headset, and you'd get a 3D stereo view of a scene. So it was very popular, but it didn't really do anything, it just gave you a static picture. So Mattel has updated this, and they've adapted it now for mixed reality. I'll show you an example. So that was very quick, but basically what, let me get back and freeze it on something here. So what they're showing here is that you can actually, you look at the disc that's provided, it's augmented in AR, and it shows you the selection of content that's available. When you focus on that using gaze detection, it activates that content, and then you're pushed into a VR view, and you can look at it as a 3D panorama, or a 360 panorama, right? So they've had this on the market for a little bit. The unit, I think, sells for about $30, and they sell the discs. It's been very popular in the US. But it's a way for them to distribute content with a combination of their own viewer and a set of what they call experience reels that are really just AR targets that unlock content. So this is another, this is called Germbuster. This is by Realitier. It's an independent developer. We have this demo at our booth as well. But basically what you're doing here is you're in a VR game, but you're using this target to position your gun in the game. And you use it to shoot little germ creatures that are in your bedroom. There's no audio. But you can see using the device camera, he's using Vuforia, and really that target is acting as the controller, so as he moves it around and positions the gun in the scene. And then he blows up these boogers or whatever. My PowerPoint just cracked. So this is an app that's known as Vuforiaro. And this is an enterprise application. It was developed to visualize a proposed development near the Vuforiaro airport in France. And so it's really used to visualize an architectural plan, effectively. And what's interesting about this one is that it starts actually in a handheld mode. So you're holding the device, you're looking at a schematic of the architecture. You select what you'd like to see in VR, and then you transition to a VR experience by just taking the device and slipping it into a headset. So I'll show you how that's done. pretty simple, you know. But it's been a very effective sort of user experience that we've seen is that a dual mode application means that you can create an app that is fully functional as a handheld application, but it can also be used with a viewer so that you can distribute it through an app store. 95% of people that just have a phone can use it immediately, but those that actually want to have a VR experience can just slip the phone into the viewer, and it's functional also as a stereo rendered VR application. So, as I mentioned, we've begun supporting viewers in eyewear over a year ago, and we continue to increase the features that we provide to make it easy to develop with these kinds of technologies. As of Vuforia 5.5, which came out really just a few weeks ago, we have a full standalone VR capability, meaning that there's no dependency on cardboard or Gear VR. You can really deploy an AR/VR app that has a full VR functionality right out of the box using Unity. And the way we've done this is by introducing support for stereo rendering using distortion correction, also head tracking and hand tracking using rotational inertial tracking technology, and a new mixed reality controller API, which is a utility class in Unity that makes it very, very easy to create experiences that transition between a handheld experience and an eyewear experience, and also to transition between AR and VR. It does a lot of the sort of housekeeping of setting up the cameras, setting up the rendering, setting up mono versus stereo viewports. I'll get into some detail as to what these do. So the significance of stereo rendering with distortion correction is that when you're using something like a cardboard or a Gear, you'll notice that they have wide-angle lenses in them. And what this does, if you look through them without any correction, you'll notice that everything looks as though it's being pinched towards the center. It's what's known as pincushion distortion. So to correct for that and create a more natural view, you apply barrel distortion, basically stretch it out again. That's what we are doing, is we have a shader in Unity that corrects really for each configuration of lens and viewer. It's customized based on the dimensions and configuration of the viewer that you're using, and also for the known radial distortion and sort of intrinsic lens parameters of the lenses that are used for that. So it's very accurate as far as providing really a correction. Right? So it provides stereo render, as you can see here. It provides distortion correction, and it's actually can be customized to a range of different viewers, whether it's Google Cardboard, Gear VR, the Zeiss VR1, and we have a set of settings that I'll show you in Unity that you can just select them. You don't need to know the parameters. We have them pre-configured for you. Now, rotational device tracking, you've probably heard the term head tracking if you're into VR. And what this means for rotational is just that there's a 3-degree of freedom tracking, meaning that we can understand the change in the orientation of your head, whether it's on this axis or on this axis. And so we can understand where you're looking, whether you're looking up and down, whether the user is looking left or right. And it enables you basically to understand the pose of the user's head so that you can adjust the content of the scene. It basically updates the scene camera for you. And this is really critical to to VR. It's what Cardboard does, and it's also what the Gear VR does. So what's interesting about our solution for this is that it provides head tracking, but it can also be used for handheld VR. So this is an experience where you're not using the camera, and you want to hold the device up, and as you move it, you can actually update the position of the device so that you can, it's like a VR AR experience, but it doesn't rely on any kind of a target. Basically, it knows the position of your hand by using the accelerometer and the inertial sensors. And you can combine these. So you can create an application that starts in your hand, it's using rotational tracking, really of your hand, and then goes onto your head. And with these, we're providing models to understand the rotational center of either your head or your hand. Now what you want, if you're doing head tracking, when you look at the rotation of a user's head, it's not simply on a fixed point. It's not rotating like this, right? It's rotating on your neck, and the person's head is typically lit a little bit forward, and it's a little bit higher than the rotation point. So we provide a model that does that kind of adjustment. It's like a head grip, effectively. We do the same for your hand. And these are really rotational offsets that provide a more accurate rotational pose estimate. And what's neat about it is that we have models we provide by default, but we also provide a setting in Unity that you can go in and create your own adjustments. So if you're building something that, let's say you're using a hand model that maybe you want to use with a robot, so it's not a human arm, but it has a different configuration, you can actually adjust it so it might work properly with that. Or if it's for someone who's gigantic and they just have, their ergonomy is different from a standard person, you can adjust the head model. Or for kids, they'd have a head model that has a slighter offset than what you would have for an adult. So you can fine-tune the rotation model. And the final element here is the Mixed Reality Controller API. Now, what this does is really using just a single method call, enables you to define what mode your application is in. Is it in an AR mode or a VR mode? Is it in a handheld experience or is it a viewer experience? And so, you can combine this. You can have a handheld AR experience that you transition into a viewer-based VR experience and back and forth. You can go from VR to AR in a viewer and then go down to, let's say, AR in your hand. And these are really just a set of calls as part of the call sequence in your application. And again, we make it very easy. What happens when you're transitioning behind the scenes between AR and VR is that you have to turn off the device camera, you have to turn on video background rendering, you have to change other elements of scene rendering, you have to set up the stereo rendering for any of the viewer-based experiences. So this really does all of that behind the scenes. You don't have to execute that call sequence yourself. So now let me get you into Unity. And I'm going to show you how you can create an AR/VR experience in Unity. And just to recap quickly, Unity is our primary development tool. We support that for iOS and Android. Windows 10 support is coming soon for Surface and HoloLens. And we also support Android Studio for native development on Android and Xcode for native development for iOS. And again, we'll provide a native SDK for Windows 10, and that'll be through Visual. Okay. Now, I'm assuming everyone's pretty familiar with Unity, but what I'm going to do is just give you a quick and simple recap of what you're looking at here. So this is the Unity editor. That's your scene view, obviously. These are your inspectors. These are all the properties of the scene that you can configure. And when you look here, we have our project, and there's my hierarchy. So that's really the scene graph, right? Now, when you're working with Vuforia, you go to the Vuforia development site, which is developer.vuforia.com. You can get our Unity extension, which is just a Unity package. You download it, import it into the environment, and it's going to give you a set of prefabs that encapsulate all of our features. So when I talk about image targets or object targets, those are all delivered as a specific prefab, and you just drag them into the scene. So it's all authored. Every Vuforia application is going to use an AR camera. The AR camera is really both your device camera in the scene and also the scene camera. So it makes a correspondence between the physical camera on the device and also the scene camera that you're using to view the scene, obviously. So for virtual reality, and using a viewer, what you're going to do, to answer your mail, is come over here, and by default, the scene will look like this. If you come to the digital eyewear behavior, this scene now is just currently set up for a standard smartphone device, right? You added your AR camera. You'll come in here, and if you look at the database load behavior, that's where you're going to load your target. It's where you acknowledge which database you want to use, where your targets exist. So you'll load and activate those at runtime. When you want to use a target, you drag the image target prefab into the scene. You select here which database to use, and which target to use. And then when you want content to be rendered when it's detected, you simply make it a child of the target instance. So the mountain here will appear when the image target is detected. And it's that simple. If you want to, the basis of any Vuforia augmented reality experience is to add to database the AR camera, add a target, define the target to be used for that image target instance, and then add your content as a child of that. And the rendering and tracking will be handled automatically. So now to set this up for VR, what I'm going to do is come in and you'll see on the digital eyewear behavior right here, you select the eyewear type you'd like to use. So I'm going to set this up for a Gear VR hardware type experience or video see-through. And when I do that, it opens up a whole other set of properties. These enable you to choose what kind of a viewer you'd like to use. So we have a generic hardware viewer, VR1, Merge, which is a foam viewer, a bit like cardboard. They really make it for kids, and so it's foam, because they fall over. And then also standard cardboard, and you can also here, if you're interested in developing your own VR headset, you can use the custom setting, and you can actually specify all of the custom parameters that we provide by default with these viewers. So you can set the lens distance, radial distortion, principal points, the orientation of the lenses in the device. And then to enable rotational device tracking, come down here to the device tracker here and simply check this box. So what this is doing is it's enabling rotational tracking using the accelerometer just by default. So as soon as when you build the app, this will be enabled without any other API. And you'll notice here again, you can define this for either a head-based experience, or you can define it for a handheld experience. So we're going to do head. And this is again what you do with cardboard or something like that. And you'll notice here we provide, as I mentioned, a custom model transform. So you can really customize the pivot point that you'd like to use. And again, this is the rotational offset. So the recommendation is that you would use the default. We've used the values that we know to be good, that are consistent and standardized across really human populations for our physiognomy. But that's what you would use to configure that. So let me show you the application of this now. Actually, I'll take you in and show you what this would look like. So we have a feature called Play Mode in Unity. And this is really a simulator that runs in the Unity environment. And so you can, without having to push your app to a device, you can just use a webcam. You plug it into your laptop or your PC, you select which cam to use here. You'll need to add a license key from our developer portal. Even to use this, it's free to use, but you need to get a key from the portal. And then you hit the play button here. Okay, it's because I'm trying to do a demo. I think that it's going to correct me, but let me take you into the other scene. So this is our AR/VR sample. Now this is something you can get again at the developer portal, and it provides you a project in Unity that's really been pre-built so that it has all of the features of an AR/VR experience that you would need to get started. And it provides also what's called a transition manager here, which is just an object that enables you to designate which content should appear in the AR mode of my experience and which content should appear in the VR mode. And it basically implements a behavior that enables you to use gaze detection. So by looking at a predefined object in the scene, what you're doing is raycasting when you're looking at it, or when the user is looking at it, it'll execute a countdown of about 1.5 seconds. You can set that as well. But once that's over, it implements a fade to black, sort of like in a movie, and then it transitions into the other mode. So you use that if you start off in AR to transition then into the VR mode of your scene. So when you're looking at this, as I mentioned before, we have the AR camera, we have our image target, which is behind the scenes. It's behind that target right there, behind the content right there. We have the transition manager, which here again you're using to define which object should appear in VR and which should appear in AR. We're defining a transition time. And then I've also come in and I've modified this a bit to show the use of the mixed reality controller. So I've added a canvas, and on the canvas I've added a button that is really telling the scene to transition. So when you look at the transition manager, this again is a script that's provided as part of the sample, and I've just extended it here with this change mode behavior that's executed by the button. So what this is doing is it's simply asking, what is the current mode? Am I in AR or VR? Am I in a handheld experience or am I in a viewer experience? It queries that, and then using the switch statement, it simply says, okay, if I'm in a handheld AR mode, transition me to a viewer-based AR mode. So what I'm doing here is saying, I'd like to transition from handheld to an eyewear type of experience. And then if I'm in a handheld VR mode, I'd like to transition to a viewer-based VR mode. If I'm in a viewer AR, I'd like to transition to a handheld AR. And so it's really just looking at what you're doing, it's toggling into the alternate mode for that kind of an experience. And as I mentioned, this then enables you really to reset the mode of the experience with a single method call. All I'm doing then is coming down here, using the mixed reality controller class. It's a singleton, so it uses a single instance, and I'm calling set mode. And that's really it. That's what you use to transition from AR to VR and from handheld to a viewer-based experience. Let me see if I can get play mode to run again. I think the internet connection may be causing an issue, but let's give this another shot. Good. Thank you. So here's our stereo render, and you'll notice there's barrel distortion applied to it. So I had set this up in the other scene. This is really just the default configuration. And you'll notice now, when I come down and look at my target, it's capable of recognizing it. Right? So this again was part of the workflow that we showed you, was that I defined a database that includes the stones target. I added stones as the image target instance. And then I've added this mountain really is the content. So as soon as I look at the target, the mountain is ready. And then when I look at the VR element, it's going to transition me into this VR scene. Now this is fully immersive. I can't track this because this doesn't have an accelerometer on it, right? But if this was on a device, and I have an example I can show you back in the booth, is you can actually track this without having to use the camera. Now the significant thing about the change mode here is you'll notice we started off in stereo, but by selecting this, I can easily transition it into a mono view, meaning that this is what you would use on a handheld device. So you can go back and forth. It handles all of the camera setup, all of the stereo rendering setup, and it's all done automatically, so you don't need to do it yourself. That's it. Yeah. So are there any questions? Hold on one second, there's a guy who's trying to get a mic. I think we're going to do the Q&A. We'll get this guy a microphone.
AR에서 마커를 등록을 하고 그걸 카메라로 비출 때 마커가 만일에 가장 멀리 떨어져 있는 상황에서 마커를 인식하기 위해서 중기등을 넣으려고 하는데 그게 코리아에서 인식하는 AR 카메라로 이용해서 줌이 되는 작업이 안 되더라고요. 그 부분에 대해서 될 수 있는 방법이나 이런 걸 좀 알 수 있을까요?
I don't speak Korean. Can you translate? Oh, okay, okay. This is going to be interesting. Yes, I can.
AR 부포리아 현장에서 AR 프로그램을 만들었는데 이미지 마커를 등록을 하고 그 마커와 모바일 디바이스가 멀리 있는 경우에 이걸 줌을 당겨서 인식을 하고 싶은데 부포리아에서 하는 AR 카메라로는 줌이 안 움직이더라고요. 그 부분에 대해서 해결 방안이 따로 제공되는 게 있는지에 대해서 한번 알아보고 싶습니다.
So, unfortunately, no. The thing is, when we calibrate for the camera, it's for a single focus setting on the camera. You can adjust autofocus and get very fine focus, but if you really zoom the camera, it changes the calibration so significantly that we can't predict what it might be. So we support device cameras really for their standard zoom setting, but not for a more extended zoom. Yeah.
감사합니다.
I'm actually using Vuforia로 to create my own content.
Yeah.
And then I have two questions about one thing is I saw the demo outside and switching AR to VR was so impressive. And so there was the track point in the middle, so I can select an object by looking at it.
Mm-hmm.
So could you explain me more about this, because I think that leads me more interesting point to with the UI interaction and everything.
Right. So that's shown in the demo that I have, the AR VR demo. It's what's called gaze detection, which is that we have a little retinal point that you would see. We put it right in the center of the user's field of view, and basically all it's doing is what's known as ray casting. It says in the Unity environment, it says, look, take an imaginary beam and cast it through that reticle, and if it hits something, tell me. And so that's what the interactive behavior is, simply looking at the center of the user's gaze. They're directing it by moving. We're doing then ray casting, and Unity has APIs that it can detect when the ray actually touches something. So that's how we can tell which object the scene is being hit. Does that make sense? It's a bit like collision detection, but it uses ray casting.
So, for example, if I see the VR interior application and someone wants to change a wall color or pattern, so if I look at if I stare at the wall for 2 seconds and then all the options comes up.
Yeah. That's how you would do that. I mean, I don't have the Unity environment up, but come to the booth and I'll show you. We have a very simple, it's really just a game object that we've created in the scene. And that's what it does, is it does ray casting, and then it performs the countdown. You want to have a little bit of a delay so that it's not picking up everything that the person may look at as they move around. So you want them to focus on something.
And the last question is, maybe I'm not following using Vuforia right now, but whenever I try to build my ADK from Unity, before I do that, I always test it with my webcam.
Okay.
Yeah, but in the Mac, there will be no problem, but in PC, I cannot connect my webcam into a Unity 64-bit.
Oh, okay.
Yeah.
So we support, on Windows, we don't support Unity 64 currently. So that would explain that.
So I look on the forum and everywhere, but not many people are answering it.
People haven't been using it. Yeah, that's why so currently use Unity, on Windows use Unity 32. For OS X, on a Mac system, you can use 64 or 32, but if you have problems on Windows, it's probably because of this.
Yes, I was so curious.
Yeah. We're coming with that. That'll be soon.
All right, thanks.
Yeah, sure.
안녕하세요. 저는 이미지 타겟을 이용해서 뷰포리아 SDK를 이용해서 어플리케이션을 만들었는데 이미지 타겟 위에다가 오브젝트를 올렸을 때 심한 움직임이나 좀 인식이 잘 안 되는 부분이 있어서 오브젝트 떨림 그런 부분에
There's a couple of techniques. A stronger target tends to be better as far as more robust tracking. The other thing you can do is to use the rotational tracking I had shown you. So what you would do is use the image target, activate rotational tracking, and what you'll see then is if you make your content part of the camera as a child, I can show you this one, is when you, even if you lose tracking, it'll still maintain its position. Yeah. So that's a technique. Another is to potentially filter the pose of the target, which will smooth things. And so do you see things shaking, or do they just disappear? Okay. Yeah, you can potentially filter. Yeah. Also, typically, though, if you have a good target, you can avoid a lot of it. So it would make sense either to maybe use a bigger target or to use one that has more features.
Yeah. 360도 뷰 카메라를 이용해서 AR 그 오브젝트를 인식시켰을 때 잘 동작할 수 있을지 그게 궁금하고, 그게 만약에 잘 된다면 그 뷰를 정지한 상태에서 3D 오브젝트만 움직일 수 있도록 해서 가상으로 바뀌는 게 가능한지 궁금합니다. 그러니까 AR에서 VR로 바뀌는데 AR이 360도 뷰로 해서 보여준 다음에 그걸 이제 VR로 바뀌는 게 가능한지.
We can do 360 view in AR. It's the question, when you say use a 360 camera, do you mean capture, do you mean use a panoramic image as the camera view?
Yeah.
So we don't currently support that. It's because it's such a wide angle lens. Our technology is tuned really for device cameras, which is like, I think 270, something like that. It's not nearly a full panorama. But it's an interesting feature to consider because we've looked at being able to use panoramic photography and to detect images within that, but we don't currently support that capability. Any other questions? Okay, thank you.